Okay. All right. So, some new stuff. We've been talking the limit as you approach from the left and right. Some nattering nabob of negativity said, hey, why don't we have a phrase for that? Great. So we have to do that now. How do we do that? We would say the following. The limit as x approaches the value c from the right in this function. Okay? That's our notation. Just the right-hand limit coming in from the right. That's our value. Do not say from the positive side. That's technically incorrect. Limit x c with a little minus sign up there means the limit is x approaches c from the left. New notation means virtually the same thing. Okay? A limit only exists when the limit from the left and the limit from the right are equal to each other. Okay? That's how it is. One way to define whether something's got a limit is the limit from the left and the right are equal. Am I speaking good English? Ready? Good spark? Okay. Now, we have to occasionally test for what's called continuity. Does a function continue? Does a function continue? If a function continues, if it goes through that point, just move along every graph you've heard till now, you didn't think about it too hard, right? It is not continuous where there's asymptotes or holes, correct? Yeah. Now we can talk about where it's continuous and where it's not continuous. First of all, a function that is unbroken, has no holes, is considered continuous. It's considered continuous at a point if and only if the limit from the left, the limit from the right, and the value itself are the same. In other words, as I'm approaching 2 from the left, we're approaching 2 from the right, and the value is actually 2, that means it's continuous. Okay, Ms. Plucker, that makes sense? A lot of words to do something you think you already know a lot about, right? Don't panic. You already know a lot about it. Now, there are two types of discontinuities because we need more language in this class. What are the two types of discontinuities? There is removable discontinuities, which means a limit exists, but the point itself does not. It's missing. We call these things holes most days. We call this a removable discontinuity. Okay? On the front, removable discontinuities. So on the left, A is a removable discontinuity. Why? You approach that point from the left and right. You're at the same value, but the point itself is not there. Ms. Fuller, you good? Ms. Fuller, you good? Okay, let's move forward. Non-removable is when the function approaches from the left and approaches from the right, two different values. That's non-removable. Why? The limit does not exist. Okay? That can be an asymptote, but it doesn't have to be. It's when the values do not approach the same number from the left and right. Then the limit does not exist. For what? Yeah. For values of y. It's always the limit. Yeah.
And for removable discontinuity, there can still be a value at the limit.
There can still be a value because the test is the limit the same from the left and right. As long as that's true, it doesn't matter what the point is. As long as it's not in the hole. Right? If it's in the hole, then now it's continuous. Okay? So removable discontinuity if it's a hole, non-removable discontinuity if it goes to two different places. Happy? Doesn't matter. That's still a removable discontinuity. The limit's the same from left and right, but the value is not in the hole. It's not continuous.
What if there's a line and another line that's detached and a point somewhere else?
That's a non-removable discontinuity. The limit does not exist.
Okay.
Yes.
Sorry, could you repeat that non-removable?
So non-removable discontinuity is the limit from the left and the limit from the right are not the same value.
Okay.
That's a non-removable discontinuity. It's a break. It looks like this. This value is also called a jump discontinuity.
No, I meant
Removable is the limit exists, so the value from the left and right are the same, but there's nothing in the hole. Right? The value's not there, so it's discontinuous. limit exists, but the value is not in that hole, then it's not. Yes.
So for non-removable discontinuity, it doesn't matter if both circles are open or closed.
Doesn't matter. Doesn't matter. It's the limit does not exist, therefore you can't. It's going to do it twice. All right, with that in mind, everybody look at the left. Sorry, look at my blue back. Let's try number 1. It says identify the point 3, 1. They're asking the limit from the right, the limit from the left, and the actual limit. Figure out what those 3 values would be. So for the point 3, 1, what's the limit from the left, the limit from the right, and what's the value, what's the limit altogether? Oh, and discuss the continuity of the function. All right, Stambridge, I've got you completely wiped out. You ready?
I finished it.
Okay, number 1, what do you got?
I got the limit is 1 and it's a continuous function.
The limit from the left is 1. Sorry, the limit from the right is 1. The limit from the left is 1. The limit is 1. The function's 1. So it's continuous. At x equals 1. Perfect. Okay. Number 2 should be super boring. You're going to try number 3. Try number 3. Number 2 is pretty boring. It's the same thing as number 1. It's next to the function. Left, right, the same. One side is the same. All right, Miss Pablo, you ready? Okay, number 3, limit to the left. Sorry, limit to the right is?
0.
0. Limit to the left is?
0.
And what kind of continuity or discontinuity is it?
Removable.
Sorry, movable discontinuity. Perfect. You got that? Movable discontinuity. All right. That's a bell rate. 41.
Isn't there a hole in number 1?
I don't see that as a hole. I thought that was not. Not a hole you get with this. All right, please listen up. For homework, I would like you to get through the previous sheet, everything you need to get through, and then I want you to do 1 through 7. I want you to notice the following on 7. It says the limit is x approaches 5 with a little tiny plus up there. Little tiny plus up there. I understand. You notice what I'm saying. I want you to notice the following. X approaches 5 with a little tiny plus up there. That has meaning. If you try 1 through 7 for homework plus, make sure you get the previous sheet done. 1-8. If you did not get that done, finish it.
And then what is the probably due?
Probably due next Thursday. If Tuesday, subject won't be in on Thursday, so I'll let you do it on Friday. So if you get to sneak out early, don't fall now. Cheers. I like those balls. We're going to take the elevator. Where are you going, Cardiel? You guys going? You guys can go now. I don't know. 41. I'm not. I don't care about bells anymore. Yes. Yes. A recommendation, yes. Okay. Yeah. Waiting for me. I'll take more. Oh, go on. Okay. Yeah, go to your next class. Come on, just go to your next class.
Oh, wait. Ow!